Scientists have learned a lot about the health of the Great Barrier Reef over the last decade, especially how warming ocean waters are harming the world's largest living structure.
The vast majority of the reef has been challenged in the last 10 years.
Much of the damage has come from mass coral bleaching. Bleaching robs corals of their food source, leading to starvation and death. There have been 4 wide-scale bleaching events since 2016. They're becoming more frequent, giving the reef less time to recover. Scientists know that even if we address climate change today, our oceans will continue to warm for some time before any benefits are realized. So they're focusing on finding ways to better protect corals by helping them to adapt to extreme conditions, become less stressed and more resilient. Researchers at the Australian Institute of Marine Science have been raising young corals in extreme conditions, including higher temperatures and higher acidity levels, a byproduct of increased carbon dioxide in the atmosphere, which oceans absorb.
Testing whether we can enhance the tolerance of offspring by exposing baby corals and the parents to future climate stress.
That includes selectively breeding these heat-tolerant corals and using genetics to help populations better adapt. Those young corals are being transplanted onto reefs through technology that helps protect them from competing organisms and grazing fish. Researchers are also working with probiotics to boost the health of young corals.
There is indications that potentially by altering their microbiomes, we can increase their resilience to disease and stress.
Another technology being tested here involves a kind of reef sunscreen to help reduce the harmful effects from sunlight.
They're seeing too much light and they're seeing too much heat. The amount of oxidative stress within the tissues, just like when you get a cold or a flu, corals are basically going through a really severe fever.
Scientists say one of the keys to helping reefs recover is a better understanding of the breeding process of corals. That's why they've created this room where they've successfully tricked corals into thinking it's their spawning season, which usually happens only once a year.
These have been raised in captivity their entire lives. They've never seen the reef, they've never even seen the outdoor light. Getting these to spawn, which we've done, and settle into juvenile coral means we've created an F2 generation and closed the life cycle of 4 species of coral in captivity.
Scientists hope the techniques being developed and implemented here will benefit other reefs around the world that are also being impacted by climate change. Greg Navarro, CGTN, Sydney.